Okay.
Yeah.
All right. So under week 5,
I haven't run into a whole lot.
okay, there's 2 recordings. You don't necessarily need them, but there's some stuff in here that will help you. So we're going to talk about them slightly. I did not make one of them. I made partial of the other one. We're going to talk about what I labeled as Lecture 3, ICMP uses. Because it'll actually come in really handy working on the second part of this project. Okay, ICMP and how it works. Okay, ICMP stands for, anybody?
Internet Control Message Protocol.
Internet Control Message Protocol, very good. It's really for checking connectivity. That's pretty much what it's used for, okay? It says report errors in datagram processing. Did it get there? Did it not get there? That kind of stuff, okay? Has benign origins. It says simple, but has been altered for malicious use, okay? Hence the ping of death. You all seen Warriors of the Net? If you've never seen it, you need to watch that. I'll just show you where it's at so you can go watch it later. Warriors of the .net. You never seen this? Oh, you need to watch this. It's a classic.
He came with a message. With a protocol all his own.
Yeah, the movie's up there. Come on, show the rest.
A dangerous far worse than his TCP/IP.
So, I mean, it's a cheesy one, but it's kind of cool. We actually showed that. So, yeah, you're right at the very top and click on see the movie. Okay? Warriors of the Net. Okay? There's filtering issues, there's routing issues, there's lots of issues with it. Okay, unexpected uses. It can be used for scanning, ping scanning. Are we all here? Tunneling, denial of service, Smurf attacks. Lots of different things it can be used for. And I can't switch slides. Okay. Message formats. It says runs on top of IP. It must be implemented by any IP module. Okay. It's protocol number 1. It's kind of important, especially when you want to identify it. By the way, these slides actually came from when I was at University of Tulsa. So you'll see references to University of Tulsa throughout them. Okay. Yeah. So the next one's actually from my friend up there. So it says messages sent using basic IP headers followed by ICMP messages. Okay. ICMP headers are 8 bytes long. That'll help with part 2 a little bit. Payloads may contain data depending on the type of the message. Like a ping actually has some payload, stuff like that. Here's the message types. You will need this for part 2. Reply, destination. Okay, I wonder how ping works. Obviously, if I want to talk to Tony, I send a ping and he replies to it. Easy enough. So how does traceroute work? Well, say I want to figure out how to get to Google. But actually, we can do that. Let's do a CMD here. TRACERT www.google.com. It's going to show me the first hop. Maybe. There it goes. Then it'll give me the second, and so on and so forth. Some will return names, some will not. Okay. What's happening is you can see the 1010, 254, 254 is actually our router for our internal network, which is down the hall. 164.58.104.193 is our connection at the firewall of the school going out. Then the rest is one net and wherever it's going from there. So, but how does it know how this works? Well, what it does is sends a packet with a time to live on it of 1. Hits the first router. Up, you're expired. Reply back. So we retrieve that, we receive that reply, and we know that's the first hop. Then we send another packet to Google with a TTL of 2. It goes out through the first router to the second router, then expires. Then we send it with 3. Goes through the first 2 routers to the third router and then expires. So that's how we're doing it. We're actually getting the expires back.
I can never get my trace route to work perfectly with Google. It always leaves out the last few.
Yeah, they're not the easiest, and sometimes they give you a lot of it. Let's try Microsoft.
Usually that's
the whole ICP protocol is blocked at a lot of places. And yeah, I mean, you really don't need it. But let's see if we get something from Microsoft.
It is for V4. It won't be for V6 as much.
Yeah, you don't think so?
No, because path MTU is a requirement for V6 to work properly.
That's true. Yeah. Max, come on, show me.
You can do it in V4, just not widely implemented. But in V6, because there's a minimum packet size of 1,200 bytes, if you're going to run less, the expectation is you're going to have 1,500. But if you're going to run less than that, then you have to provide a path MTU response telling the originator drop your MTU down to below this.
All right, Sarah, to get to MSN, you see we went through, it looks like Chicago, maybe? RTSW chick, I don't know where that one is, but it went through, we got some partial names now at least. So MSN obviously is a longer route to get there. Okay, so we have some different message types with it that will become important with part 2. Okay, differences with TCP and UDP, no port number. Okay. Service identifiers by type and code, just a bunch of different things that, that you might come in handy, but it's just different. So, simple request replies is how we normally use it. Okay, you can also do delivery rate, stuff like that. Y'all see AT&T changed their wire, and we got AT&T in here. Okay, Patrick, you got AT&T? You probably have Verizon or something, or nothing. T-Mobile?
Yes.
Oh, but then you got no more overages. So you can no longer run out of data with AT&T.
It's the same way with mobile. I mean, you get throttled.
Yeah, you get throttled massively. But, I use Wi-Fi here, Wi-Fi at home. Really, very seldom do I use data. So once I...
Over here, T-Mobile's doing this thing now. They used to have a feature where, you could get it cheaper if you agreed to have your videos throttled. Well, now they're making it so all your videos is cut down to 480p, and you have to pay to get it in HD.
What? That's for T-Mobile?
It's bizarre. That's like it's being put over this.
Wow, never heard that. Never heard that. Okay. So, ICMP echo requests are blocked by most major places. Like, in a normal never care row state, you cannot ping outside. Because why do we need to ping outside? We don't need to. We just happen to be able to do it here because we manage our own network. So, different settings that pertain to ICMP. They talk about how it normally works. Okay. Again, this will come in handy when you do the next part. Okay, we're not going to go in great depth. Port unreachable is another one that's kind of handy. Yeah, we're not going to go into each one. There's all kinds of settings we're not going to mess with. But I provide this to you so you can possibly, you really need the beginning sections on how to identify ICMP. Okay. Smurf attacks, it was actually one that was on a test I took. I think it was the Christmas attack. But they do a decent job going into all this stuff, explaining it to us. Now, the next presentation, again, this stuff isn't required, it just might come in handy for you. The next presentation was not written by me. It's 100 slides long, or 99. It was written by Glenn Jones. He was, when I was up in TU, he was one of the guys up there that was good. He took great notes, he always made it in the PowerPoints. So this one has a lot of notes pertaining to Nmap and Ethereal and routing and all addressing and TCP dump and all that stuff. Okay, so look through here. Some of the tools he uses are outdated because they're actually made quite a bit ago. Obviously, Ethereal's gone now. I mean, even tells you this happens when you don't get a ping, stuff like that. Okay, so I did put this up here. It even tells you what a ping does, how the ports work. Okay. Talks about OS fingerprinting will become very handy for that project you got to do now. Talks about exploitation phase, and then he has review sections at the end of each chapter. What he did is he would take notes in classes and then kind of make his own slides based on it. Okay. Satan, actually, we used that in one of the class. I think we used it in the Cyber Patriot class. I can't remember we used it. Nmap. Obviously, we use a lot. Nessus. don't really use PingPack Pro much anymore. There is a lot of automated tools out there. But he made a very good network here, and I tell you, if I asked you guys, I don't want to put you on the spot here, but to scan a network, I'll write a network ID up here. 10.10.0.0. Okay? If I asked you, man, I hate that they mapped it to stinking, I wanted Notepad, but tools, configure preferences. Hold on, I gotta fix this. Text, font, 20. Let's go with bold. There it goes. Okay, so if I was to give you that network ID and told you to give me the CIDR, that would give you 30 usable IP addresses. Everybody know what the CIDR would be? /27. Okay. I told the students, originally I said, scan the network that returns 32 IP addresses. So they gave me /32. No. Then I said, no. 30 usable. They said, 30. No. Like Tony said, was 27. And what that does for us, it's the number of ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 24, 25, 26, 27, and then 5 zeros. Okay? And the number of hosts, you go by the number of zeros. 2 to the 4th is 16. 2 to the 5th is 32. 5 zeros is 2 to the 5th, so we get 32. Can't use the first, can't use the last, you end up with 30. But I asked them that because I want them to try to remember prior classes they've already taken. It's not going good. Not going good. But I couldn't believe it. I says, yeah, 32 IP addresses. There you go. No, that's not even valid. It won't work.
You can pin yourself.
Yeah. But then Mappa don't like it.
Local host
So
ever
I guess when a large corporation wants to type /10,468.
Yeah, that would be first. Yes, I want a very large network. Yeah, let's do 4096. But when I told the guy, okay, how about 30 usable IP addresses? Okay, 30. I'm like, no, that's not right either. So I try to bring that in there. But these set of slides do cover quite a range of items, and some of them would, I mean, this is Nmap version 1 for Windows. That's some old stuff. A lot better ones out there now. So I put this up there so you can look through it. It can't hurt. Okay? Right. And there's a whole big old section on OS fingerprinting. And just so you know, these slides were made about the same time that this assignment was originally made. So these switches would be perfect at this point. But yeah, he goes pretty in depth on OS fingerprinting.
OS fingerprinting is hard.
Yeah, it even tells you how to do it on XP Pro. So it's kind of cool. Kind of nice. Okay. Talks about all different scans. UDP scans, just all kinds of stuff. What was that software? Zone Alarm. Wow, that's old. Okay. All right.
Does it still exist?
Probably. Okay. So you are welcome to use this as a resource. Well, again, it's not required. It just happens to have a ton of stuff. Okay. Talks about all the different switches and what they do. Okay. Then the Nessus gets into everything. Okay? Alright, so your mission is to do that first set of questions, and next week I need to modify the second part of the assignment because you'll be lost the way it's currently written. So, okay? Everyone okay with what they're doing? What you're gonna, any questions before I close this out? You got a bunch of man pages up here. You got a whole bunch of IEEE stuff. I mean, it will literally tell you everything. Everything. So every possible value. I mean, wow.
That was the man page for a second one. That's what I heard say.
No, that was the 802.3, the Ethernet. I had a student a few years ago. You know all the 802, 802.3, 802.5, 802.11, 802.8. Do you not remember those? 802.1 is internetworking. 1 is like an I. 802.3 is Ethernet. A 3 is the E backwards. 802.5 is token ring, 5 golden rings. 802.8 is fiber optic. 8 is oct in German. 802.11 is wireless, because you got the little antennas up there. Actually worked, I still remember them to this day. So, alright. So that's what I want you to do for this next project. I'm going to give you 2 weeks for it. I'll have the questions. I got most of them done now. I got to work on the wording of them. See, it's actually up there. I just can't show it to you. See, just so you don't think I'm lying to you. See, it's actually there. See, and I even have, the first 6 questions are all in there already. I just got to change the wordings for some of them so they're not quite as ambiguous. Because I can see Tony answering some of this stuff. But technically, so, you would. So,
Okay.
yeah. But it's
You
fine.
would think about all of
I know,
it.
so-
You would
all right,
consider all
that's the end of
questions
this.
too.
All right.